welcome back. For those of you who are wondering if you're now in the wrong conference, you're not. We're going to talk about new steel, making new steel, and we're not going to talk about reclaimed or reused sections at all for the next hour. So try not to switch off, because I know that's not what you signed up to. But we're doing this for quite an important reason. We heard a few people speak this morning about the need to think about our use of steel in terms of the slightly bigger picture. You can take a reclaimed section and put it any way you want into a new building, and it could work with basically zero stress going through it, and you'd pat yourself on the back for reusing some steel. But the reality is, for every ton that we reuse, we are missing out on recycling that ton. And so we have to think of this broader picture. There will be times when we can't use reclaimed sections, and there will be times when using a reclaimed section would be inefficient. And I think it's been brought up a couple of times this morning that, generally speaking, if you could design a new frame for 25% less tonnage than your reclaimed equivalent, it's better to send that material to be recycled on a sort of systems view. So for that reason, it is important that we talk about new steel, and it is important that we sort of pair the two together contextually in our head. And a couple of us were actually just talking over lunch about, I think if you gaze far enough into the future, you probably come to the conclusion that, you know, maybe 50 years from now, we won't be having conversations about, is it reclaimed steel or is it new steel? It will just be steel. And probably those supply chains will have sort of blended it all together. You won't really know where it's come from in that sense. You will design, and a lot of it will be reclaimed, and a lot of it will be recycled, and maybe a tiny bit of it will still be new steel. So we have to keep the contextualized, you know, the two bits together in our minds. So yeah, apologies. We're going to talk about new steel for an hour. We're also going to try and prioritize talking about today's emissions and things that we can do on today's projects. We'll do a bit of future gazing, but it's mostly going to be about what we can do today. So with that, we should probably introduce ourselves, and I probably should have done this before I started talking, really. My name is Will Arnold. I work for the Institution of Structural Engineers. We're a membership organisation dedicated to the art and science of structural engineering, and I'm their head of climate action, so I deal with all of their sustainability gubbins. Matt?
Thank you, Will. I'm Matt Teague. I work for Tata Steel. We make new steel in South Wales, in Port Talbot. I am by profession an architect, but I've worked in the steel industry for 23 years. And latterly, I've been most involved with systems building, modular volumetric, and design for manufacture and assembly.
Hi everyone, I'm Roger Morton, Director of Innovation at EMR. We're one of the world's biggest recyclers of things. We do about 10 million tonnes a year of stuff, 4 million of that in the UK, lots of it construction steel. And of course, we're really excited about the opportunity for reuse, but also we're developing new ways of recycling steel to make it possible to decarbonise new steel making as well.
Hi, I'm Dave Knight, and I'm here today representing CARES, which is the Constructional Steel Certification body, mainly dealing in rebar, but also certifies a lot of the steel mills as well that produce the structural sections. And with some other hats on, I'm also convening a roundtable on responsible recycling of metals and work with other standard-setting bodies in the metals area.
Hi everyone, I'm Sameen Khan, and I lead the Steel Zero initiative at Climate Group. For those of you who don't know Steel Zero, it's a global initiative. It brings together leading business side, demand side organizations to send the demand signal to steel makers as well as policy makers that we need to speed up the transition towards net zero steel industry. And as part of that, my role is to expand the membership base, covering all sectors and geographies, but also engaging with our members on topic-led and sectoral working groups and discussing enabling policy mechanisms with policymakers and just working with our partners, Responsible Steel, as well as the global NGOs that work in the steel ecosystem to kind of collectively address the challenges of decarbonizing the steel industry. So that's me.
And I'm Walter Swann. I'm a structural engineer, and I work for ArcelorMittal. And I just wanted to give you a very brief overview. We make about 70 million tons of steel every year, 50% of that in Europe, 50% rest of the world. We're roughly aligned in terms of the way we make steel. We're roughly aligned with the global split, which is kind of 75% primary steel making, 25% secondary steel making. So in terms of the primary steel making, 70% is blast furnace, 5% is DRI, and the secondary steel making is scrap-based EAF. And then in terms of the product range, we basically make all construction products. So sections, which is kind of what we've been talking about this morning, but we also do rebar, material for decking, material for steel fibres. And that's us.
Thank you. So, before we get into how you reduce emissions today when you are using new steel, can we start with a bit of context setting? And this is, for some of you, this will be a bit of sort of egg sucking, apologies, but it's easy after lunch. But I think it's important that we just sort of make sure everyone understands what these acronyms are, what the main routes to making steel are, and things like that. So I don't know if Matt, maybe if you want to start, could you just give a brief overview of typically steel making today and what it looks like?
Certainly. So Walter mentioned 3 acronyms or three methods: blast furnace, DRI, and BOS, EAF as well. So there are 2 primary methods of making steel in the world today. World Steel actually only measures really two methods of making steel, although there are others. One is the primary route, as described, which is making, first of all, you make iron from iron ore, coking coal, and limestone. You put it all in a blast furnace, react it, molten iron comes up, and then you blow oxygen through that iron in something called the basic oxygen furnace, and that becomes steel. That's primary steel making, and that is basically what we do in South Wales and what British Steel do in Scunthorpe. And across the world, there's approximately a 70-30 split between basic oxygen blast furnace steel making on the one hand and electric arc furnace on the other, although territories do differ to a great extent. And then you've got electric arc furnaces, and electric arc furnaces are entirely fueled by scrap. So they're basically fueled by old primary steel. And electric arc furnaces are obviously much less carbon intensive than the blast furnace process. They do require quite a bit more power. So at the moment, economically in the UK, about 80% blast furnace, 20% electric arc furnace. And the people that do operate electric arc furnaces are people like Selsa, who make reinforcing bar, again in South Wales, Forge Masters in Sheffield, for instance, and Liberty Speciality Steels. So they're used for very specific types of steel, from the very low grade stuff that tends to be used for rebar to the very high grade stuff which tends to be used for automotive and aeronautical steels, for instance. So there's a very definite split between the 2 markets. The UK, in places like the USA, there's pretty much, it's the other way around. The EAF is about 80% of production over there. You get a lot of electric arc furnace structural steel. So worldwide, the picture is quite mixed, and there's lots of different sorts of practice around. But largely speaking, we're talking about 2 basic methods of making steel, primary and secondary, and then all of the attached kind of sub-processes that are aligned to that. So coke making, for instance, sintering and annealing for ore and limestone. DRI, which is directly reduced iron, which is another way of making a basic component. And that can either go into basic oxygen furnace or it can go into electric arc furnace. So there are numerous ways of cutting the particular cake. And they all have different energy and carbon burdens and requirements.
So to pick up on a couple of those key terms then, primary steel making, so cool because it's mostly new steel. I suppose very little scrap goes into that.
Yeah.
And typically blast furnace, basic oxygen furnace. And secondary steel making is so cool because it's mostly recycled, at least in terms of how we do it over here. And you mentioned direct reduced iron. There's also a sort of primary route into EAF, but not so cool in the UK.
Like most things, it's not black and white.
Yeah.
So there's always recycled content of primary steel. We use recycled content in the blast furnace, and we use recycled content in the basic oxygen furnace. Up to about 22% is the maximum. Some people do go a bit higher, but it's quite rare. So about 25%, I suppose, is the technical maximum you can get for recycled content in new steel. And as you say, in electric arc furnace, you can actually go directly from the blast furnace with iron, put that into put pig iron in an electric arc furnace along with some other things and end up with steel. So it's not black and white.
So one of the key things you've talked there about is scrap and percentages and amounts of it. Roger, could you dig into a bit more depth on the sort of scrap availability, what problems that gives us in terms of these different methods of production, things like that, please?
Okay, well, I think there's a total of about 2 billion tons of steel made or used in the world, and there's about 600 million tons of scrap available today. So we will, for a long time, we will need primary steel making as well as scrap. The scrap that we collect today in the UK is mostly going to people who make reinforcing bar. And because, as someone already said, the requirement for reinforcing bar in terms of purity is not particularly high, we can tolerate up to 0.3, 0.4% copper in scrap for reinforcing bar. That's the way the market works, and most of the scrap from the UK is either used by people like Celsa in the UK or is exported to the Eastern Mediterranean, to other parts of Europe or the US, to go primarily into reinforcing bar. If you want to make higher specification finished steel products with a high percentage of scrap, you need to clean your scrap much more than we currently do generally in Europe at the moment. We've all got projects going on that. We have a project with Tata in South Wales where we're working together to develop new grades of scrap. But this is all very early stuff. And as we make the transition, as has already happened in the US, to much higher percentage of electric arc furnace steel production, we will all have to change the way we collect and process scrap.
So to summarise, we use 3 times as much steel as exists as scrap, and therefore, presumably if I ask for more scrap on my project, somebody else just has to get less, right?
Correct.
And so the sort of split of secondary and primary steel making probably isn't going to change all that much. The methods within those might, but you are, at the moment, we're constrained in terms of how much scrap is available.
And one thing we ought to just talk about is the carbon impact of these different steelmaking routes. So, correct me if I'm wrong, chaps, but carbon impact of the blast furnace route in the UK is round about 2,400 kilos of CO2 per tonne. If you make equivalent product with scrap in electric arc furnace, depending on what mix of power you're using, the carbon impact is going to be between 300 and 600 kilos of CO2 per tonne. So there's already a big advantage in terms of carbon impact, but of course there's a limited supply of steel. There are new steelmaking methods coming, which all these companies are involved in developing with hydrogen and direct reduction, which will bring carbon impact of primary steelmaking down to something like 100 to 200 kilos of CO2.
But we'll come back to that later, as we discussed before.
Will, can I jump in just add a little bit of a European dimension? Because we've talked about the UK, we've talked about the world, but I'm going to throw some statistics out, if that's okay, or some rough figures.
For context, how much of UK steel comes from Europe? Do we know?
Well, sorry. I think it's really important when you talk about steel to actually drill down into product a little bit, because it will be different depending on the products that you're talking about. So we shouldn't just talk about steel, we should talk about section, we should talk about rebar, we should talk about organic coated, which to you means cladding panels, we should talk about metallic coated, which means light gauge and decking, because those products are made in different ways, and they're made in the split between them is quite different. So if we talk about section, in the UK, at a rough guess, 30 to 40% of that material comes from outside of the UK. But in terms of Europe, 80 million tonnes of steel make is from scrap, and that's made in 150 electric arc furnaces. 150 electric arc furnaces, 80 million tonnes of steel. If we look at primary steel, 90 million tonnes, so not quite 50-50, a little bit less. And that comes from 60 blast furnaces. So there's a lot of electric arc furnaces out there and not so many blast furnaces. And blast furnaces have actually been progressively being shut down over the years. We as a company, 30 years ago, shut down 2-3 blast furnaces and transitioned to electric arc furnace. If we continue just that conversation about scrap, so you've got scrap-based electric arc furnace manufacture, but just to complement what Matthew said, 10 million tonnes of scrap goes into primary steel making, blast furnace steel making, so that accounts for roughly about 10% of the global the European steel make. And then if we think about scrap flows, Europe exports, a net exporter of scrap, about 20%. The United States, a net exporter of scrap, about 20%. The UK, a net exporter of scrap, about 80%. So that's kind of a more balanced view, I think, of what goes on both globally and regionally. And I think that's one of the issues that we probably need to pick up on, is that there's regional dimensions to this.
Yeah, and actually just before, Dave, before you come in, if we could flick forward a couple of slides. Sameen's got this amazing diagram sort of showing the difference between, next one, please. Yeah, between, so those blue lines are steel demand in different regions of the world, and the red lines are scrap availability. And just note that the y-axes are different on different graphs. But you can see that sort of that 1 in 3 ratio that we talked about obviously varies around the world, and it varies in different locations. I don't know, Sameen, if you want to say anything to this before Dave
No,
comes
I think
in.
it's just that to point out specifically, like if you look at India, which is like the second or third largest producer in the world, and that demand is going to quadruple, in fact, before 2050. And there's such a big disparity between the demand and the scrap availability in India and in Africa. So it's not the solution. Basically, there's a lot of inequity with scrap across the world. So that's definitely something that is in consideration when we look at the transitioning roadmap and the
And I suppose what this says to me is that, I hear people say, from a UK policy point of view, we should keep all our scrap within our borders. You say we export 80% of our scrap. Yes, that's true. Quickest way to decarbonise the UK is to keep all that scrap here. But of course, if we keep it here, the place where it was going before now has a deficit compared to what they had. So our emissions will go down, but somebody else's will go up. So, to me, these sorts of diagrams and this way of thinking is really key, because it sort of, there's a bit of a carbon whack-a-mole thing going on. You whack it down over here and it pops up over here. And I think we mustn't lose sight of that. Dave, do you want to come in?
Well, I was just going to add a little bit more context in terms of the importance of the construction industry for steel making, because, and correct me if I'm wrong, guys, but I think it's about 50% of global steel production goes into construction. Yeah. So, and then out of that, about half of that, I think, into rebar, as far as I understand. So it's very, very significant, and the decisions that can be made in the construction industry are hugely important. And then the other thing that I just want to kind of touch on in regards to this is the importance of the kind of that circular thinking and the time frame that it takes for greater scrap availability. And I'm not sure whether you're going to talk about this, Roger, but the average lifetime between when the primary steel is made before it then re-emerges as scrap. There's some debate about that, but 40 years is often given, but potentially a bit less.
Probably past 2050 if it gets made today as primary, right?
Yeah. 38 years, I think.
But another important point to make about scrap, of course, is it's not like GGBS, where it's a diminishing resource. It is a resource that is going to grow. So yes, global demand will grow, but so will scrap.
Yes.
But there'll still be a gap in demand.
Yeah, there'll still be a gap. And of course, the rate of change is going to be very slow compared to the fact that we need to halve emissions in the next 7 years.
Yeah.
Should we talk then about what you can do on projects today to reduce emissions? Because hopefully we've made the point fairly clear that just asking for more scrap won't reduce emissions, at least not on a global scale. It might reduce one of your projects. It's the whack-a-mole thing, though. Overall, things stay the same. So I don't know, Sameen, maybe you could start us off, with your Steel Zero hat on. What should people be worrying about or thinking about today when they specify steel on their projects?
Definitely. It's something that can be done today, and that is specifying steel that conforms to an international standard. So an example of that is responsible steel. Yes, this is the responsible steel, the international standard that was published last September, version 2. And what they've done is responsible steel covers 13 principles that is not only greenhouse gas emissions, but covers social and governance and the whole ESG spectrum. And they have come up with 4 progress levels, starting right from the top, progress level 1, which is the basic, the black line, the basic threshold. So what you could do on your projects today is specify steel that would conform to the greenhouse gas emissions intensity being below progress level 1 today. And that's possible. Like Roger mentioned, that in the UK specifically, the emissions intensity is 2.4 tons per ton of crude steel, and if you can see the progress level 1, it starts at around, I think, 2.8. So a lot of UK steel makers could be below progress level 1.
So just dig into what this graph just tell us what this graph is showing. So what's on the two different axes?
Yes, of course. So you've got the greenhouse gas emissions intensity of crude steel on the y-axis, and there's a scrap share of metallic inputs on the x-axis. So it's a sliding scale whereby, if you've got 0 scrap share, so it's 100% primary-based steel making, then that would start at 2.8 tons per ton of crude steel and go down to about 0.35 for 100% scrap share. That's just progress level 1. And the idea is that with every, basically, as we transition the steel industry, the progress level 1 will drop off, and then you aim to go below progress level 2 and 3, and then subsequently to progress level 4, right at the bottom, which is the near zero emissions level. So what you could do today is, you could start with saying, yes, okay, we want all our steel from steel makers that are meeting below progress level 1. And then make it more ambitious incrementally by saying, okay, by 2025, we want to procure at least 50% of our steel that's below progress level 2. By 2030, 100% that's below progress level 2. By 2035, maybe 50% below progress level 3. So you could make that incremental decision to specify steel in that manner.
So what you're doing with this graph is you're basically saying, look, we don't mind how much scrap is in it, because we know it's constrained, and so there's no point us trying to redivert it. But if you don't have access to very much scrap, we're going to rate you differently in terms of what we expect from you on greenhouse gas emissions terms to if you have access to a lot of scrap. And so if you've got 2 manufacturers both with 0% scrap, it doesn't really happen, but if it was 0, and one of them was emitting 2.8 tons of carbon per ton of steel, and the other one was emitting 2.6, there's that difference, and that helps you sort of prioritize that.
Yes, and that's what we've talked about. There will still be demand, there'll still be production of primary steel, and this is to still decarbonize the sector and to decarbonize primary steel making, to obviously get more inputs from energy, cleaner energy sources, etc. So that's what this is addressing. So it's not all about scrap, but there are other ways to decarbonize the primary steel making as well, and this is what is recognized.
And what sort of, maybe this is a Walter, Matt question, but obviously two of you come in as well, please. And what sort of things do we typically see today? So I'm not talking about the hydrogen DRI and all that, we'll come on to that in a minute. What separates, a manufacturer who sat at 2.8 from 2.6 at this end of the chart today? Matt?
Age of plant.
Age of plant
efficiencies. One of the things that I think, at least I didn't appreciate until quite recently, I've had a couple of conversations during the day about this as well, is that most integrated steel plants will be the same for any manufacturer. They're pretty much self-sufficient in energy, because those process gases from the blast furnace and the coking ovens and everything else are basically redirected elsewhere in the plant. And the emissions are actually probably calculated at the end of the process rather than at the beginning. And in order to move to electric arc, for instance, we need to replace that electricity that you lose from the blast furnace. And it's somewhere in the region of 2 terawatt hours per ton. It's an enormous amount. It's a 20 wind farm turbine somewhere. And this has a large bearing, so it's your energy infrastructure, your access to renewable sources of electricity. One of the reasons why SSAB is able to make hybrid, the hydrogen steel, the fossil-free steel, is because of their ready access to hydroelectric energy, so to make the hydrogen in a green way and then make the steel. We're a little less fortunate in this country in that we need the hydrogen infrastructure to actually happen first. So there have to be one of the other things I'd like to comment about this graph actually is that it won't be a smooth line. It'll be a series of steps, and those steps could be quite significantly large. So if, for instance, we transition from blast furnace to electric arc furnace, you'd expect to see a sort of step down, probably into progress level 3 at some point, in sort of one go. But it won't be.
And yet, when you say that, you're talking about staying as primary steel making, but that's like DRI electric arc furnace, right? So it's still new steel. So there's a significant jump in
go
terms
into
of
the
emissions.
electric arc furnace, yeah.
So you're not necessarily jumping to the right, you're jumping down.
Jumping down.
Yeah. Dave?
Yeah, so there's a little bit of a kind of gap as well, and a little bit of bridging that needs to be done between the data that's required on here at the crude steel level and the kinds of information that's typically available in the construction sector. So, and I know that there's a lot of work going on within Steel Zero and looking at the downstream requirements and how you can actually specify lower emission steels. And of course, this crude steel level is the first point of steel production. But for many of the other products that you need in construction sector, you've got to include all the processing emissions and other emissions associated with transport and other things. And so typically you get the global warming potential figure within an environmental product declaration. And so that's what's readily available kind of in the marketplace at the moment. But I'd welcome any kind of views.
So an important point to make that, Dave. So you can't take an EPD value and plot it on that graph. It does not compute. And I think that's where there's one of the gaps in the information at the moment.
So what do people take to plot on that graph if they can't take an EPD?
I think that is an issue that the industry needs to deal with. That information isn't there yet. I can take, so we as a company, we tend to produce an environmental report for each site that we have. And if you want to spend a couple of hours interrogating those reports, you can generally infer those things. So a bit of transparency on that would be useful, but I don't think it's quite there yet in terms of using that chart. I would kind of go one step further, because there's a huge thing behind responsible steel which hasn't really been mentioned. So we're defaulting to type as construction professionals. We're going straight into the figures, but actually responsible steel is about 13 other indicators. It's about the environmental, yes, but it's also about the social and the governance. So maybe the best thing that you could do in terms of specification tomorrow is focus on the governance. And that is specify steel from, for instance, a responsible steel producer or someone with a science-based target, because you know that their agenda is the same as your agenda, i.e. that you're wanting to decarbonise the industry.
I would be remiss not to mention the CARES Sustainable Constructional Steel Scheme, which does specifically apply to constructional steels and does require third-party verified EPDs within it.
Can I just chuck in a little bit of controversy here and point out that there is a significant difference of view from the responsible steel view among electric arc furnace steelmakers in the US and other parts of the world, and in the scrap sector, which is that if you follow the responsible steel guidance and buy against that guidance and say, right, I'm getting a level 3 or level 2 green steel, you might well be buying steel that has a carbon impact of, say, 1,200 kilos of CO2 per tonne, when you could be buying steel from an electric arc furnace steel maker that might have 600 kilos of CO2 per tonne. Even though that electric arc furnace steel maker might be using coal-based power. So there is a difference of view there, and it's a tricky situation to navigate, because, of course, a lot of construction and developers, people in your sector, are trying to build to a CO2 impact per square metre, and you want to have absolute low-carbon steel used in your projects. Obviously, we think reuse is the best thing, at 47 kilos, but you're going to have some primary steel for the reasons we've explained.
So
there's a worry that it might drive some dysfunctional behaviour if we only follow the rules of responsible steel, and that's why there's another group, largely driven in the US, that involves a lot of other electric arc furnace steel makers and scrap companies, which are promoting a different standard.
It's of
just
course
being controversial.
It's a supply and demand thing. It's a regional considerations as well, and the approach, obviously, with this, the responsible steel is it's an international standard, so it's meant to have everyone on a level playing field. So, of course, your Asian producers as well can meet the standards, and I think that's the challenge with sometimes just being a bit narrow-minded towards like kind of one type of solution, is that you miss out on the larger part of the world, and allowing them or incentivizing them as well to decarbonize. That gets missed out.
Sameen, who has signed up to this? Who is? Could you just give people a bit of a sort of flavour for the sorts of companies who have signed up to this?
So Responsible Steel, it's a multi-stakeholder membership. So there's a lot of steel makers, not only from from US and Europe, but Australia, India, South Korea as well. So there's a lot of steelmakers who are members of Responsible Steel. You've got civil society organizations, Steel Zero, Climate Group as well as members. There are demand-side businesses as well, like leading construction and property company Lend-Lease, they are a member. Volvo Cars, so you've got demand-side, and you've got a lot of intermediary manufacturers in the steel supply chain as members as well. So it definitely covers a large multi-stakeholder network and across the whole world. So all geographies pretty much represented in the membership.
And just Tata Steel are responsible.
And Tata Steel, ArcelorMittal as well.
Stal,
Cares,
POSCO. So there are some big steel
So
makers.
some big names involved. Dave, go on.
And sorry, importantly as well, a lot of those are primary steel makers. So just to respond to your point, Roger, that American piece of work that you're talking about, you have to bear in mind that America is primarily electric arc furnace. So they are kind of trying to speak to that process. Responsible Steel, I think, probably slightly biased, but it tries to be more moderated in its response.
Yeah, well, I mean, if 70% of global steel is primary steel maker with blast furnaces, then...
And it speaks to that.
Dave, go on.
Just to highlight that this is also the International Energy Agency and Science-Based Targets Initiative
Their
development
approach as well.
Yeah, so it's aligned to their approach. But the point of the secondary producers has got to be considered in that we do need to reduce our absolute emissions as quickly as possible and accelerate that scale. So that's one of their kind of
And I think we can all agree on that, yeah.
Yeah, absolutely.
So there's an interesting take on this, which is that stuff like this, which is about change, well, it's about giving demand signals, right, is based on the premise that we are going to need X amount of steel, and therefore we must decarbonise primary steel making in order to be able to keep up with that, because scrap will never fill the gap. The opposite mindset that somebody put to me the other day was to say that probably our policies should be based on supply rather than demand. We should probably be saying, well, we've only got X amount of scrap. How do we set policies to meet that? Which would be a very different approach to this altogether, which I don't think exists out there, but probably brings us back to the reuse of steel piece.
That might happen. That might happen by default, because once you do that, once you work out how much scrap is available, you automatically constrain your potential supply, your supply of new or secondary steel in this case. So what's likely to happen is that, in actual fact, on our site anyway, our total steel make is likely to go down if we move to a new less carbon-intensive technology, which is interesting.
Say that again. So your total amount of
total
steel
make
will
go down
if you move to secondary steel making.
And that's been
Why is
factored
that?
in. Why is that?
Because of how much scrap is available. Yeah.
I mean, there are things, to go back to the original question, what things that we can do now, and one of the things that we've been working on with people in this room and others is how you build. How you build now, you build more efficiently, you build inefficiencies to the building, you make sure that reuse is something which is factored into the design. The mention of that hangar that's been reused several times, that's one of my case studies in sort of slideshows that I do. That's a 81-year-old building which has been reused 3 or 4 times now. Twice in Holland, twice in the UK.
Yeah.
So it can be done, and it's actually been changed very little. I think they reduced the height somewhat for the bus station.
Yeah.
So it's a truncated hangar now.
And of course, if you are using brand new steel, there's once you've gone down that route, there's efficiencies to gain on that by avoiding architectural flourishes, transfers, all of those sorts of things that we should be doing anyway.
Yeah, platform DFMA, as it's known, is really a return to that kind of systems building thinking, like CLASP, like the schools movements, where you actually are reusing, like agricultural buildings and portal frames now. I mean, there's a huge trade in second-hand agricultural buildings with very little change from site to site. And it's part of the reasoning behind, most buildings have a regular grid. Someone mentioned it this morning. Most warehouses have an 8x32 or an 8x16 grid. So why can't you reuse whole buildings? as long as you know that the structure hasn't been overstressed in any way or had a fire or had something crash in, as long as you know that it's generally okay, why don't you reuse whole buildings? And I think that's something that's really, from my background as an architect, there's a lot of resistance in the profession to thinking that way because we think it takes away creativity and our ability to express ourselves. But 90% of buildings are just buildings.
I think it's
to be controversial, I mean, it's sort of most buildings don't need to express themselves. They just need to be good.
It was fairly inevitable, wasn't it, that we'd end up speaking about reuse of steel at some point in this session. Just before we go on to questions, and we've got a couple of minutes left before we do that, and do please put them on the slide. And I've also been asked to remind you can upvote other people's questions, so please do that so we get the most personal ones at the top. Just before we move on to that, we should quickly touch on demand signals that will help drive further decarbonisation. So I think what we've heard is in terms of lower carbon steel on projects today, there's not a huge amount we can do. There's an approach such as this graph that helps you prioritise one steelmaker over the other who've got the same sort of percentage scrap, for example. But we should also talk about the sorts of things industry should be doing to send signals that will bring in future decarbonisation, that will get producers to go down on a graph like this. So does anyone want to sort of share any thoughts on that, the demand side?
Could I just add in one other thing that can be done now is thinking, so a lot of this kind of material efficiency side, you can consider that it's all kind of about thinking about it early in all the different kind of REBA stages. And for example, you might want to specify a higher quality steel, which would ultimately lead to using less steel in the build because you're getting higher tensile strength.
That could be higher strength steels where it's strength governed columns, trusses, things like that. Right?
Yeah, so one example that I'm aware of is, typically rebar is 500 MPa, but if you go to 520, then you can reduce it by about 4%. So that's 4% volume, 4% less carbon emissions. And that date, so you need to be specifying that data. I think it was Andrea that talked about this earlier as well. Make sure that you specify the quality data and use it as well as the global warming potential data.
Yeah, the advantages sometimes, sorry, Roger, the advantage of going high strength often outweighs the environmental, the carbon cost.
If you go with higher strength steel, just to be clear, does it increase the emissions of the steel?
Slightly.
Slightly. What kind of order of magnitude? Few percent, 20%?
Negligible.
Negligible, okay. So if you've got a strength-driven piece of design, such as a big transfer truss, the benefits of being able to use less steel will outweigh that probably, and it'll be lower carbon.
Should do, yeah.
Be clear,
I mean,
yeah.
I can't stay for every case.
Yeah,
sorry.
sure. That's general rule.
I think another practical thing that we can all do is think about how to avoid downcycling steel when it gets recycled. So start thinking about how those circular supply chains can work. Our colleagues in our US scrap business talk all the time about the Nucor effect. Nucor are the first major steel maker that really did recycling through the electric arc furnace route in the US. And the Nucor effect is that they were putting all kinds of scrap into the electric arc furnaces with high levels of copper in them, trying to make higher grade products like sections and flat products. And gradually over time, copper was at a very low level to start with, but it's built up in the whole system in the US. So increasingly, we're finding high levels of copper in constructional steel in flat products, which makes it harder to send them round the loop again, and more likely that they'll end up in reinforcing bar, which is like the sink for the most mixed grades. So obviously, reuse that you're all talking about here is by far the best thing. I know we're not supposed to talk about it, Will, but that gives it another life of 30 or 40 years. If next time we can keep the scrap segregated or separated and direct it into a high-grade application, like maybe first time round automotive sheet or cladding panels, and then the next time keep those separate and try and get it into constructional sections, and the next time in 120 years get it into reinforcing bar, fantastic, because then we send it round the loop 4 more times than we would have done if we'd gone straight to rebar. And that's something that everyone in the whole supply chain will need to collaborate on, from design of the building, material passport generation for your buildings, through to the collection systems and the segregation and the steel makers and everyone else.
Yeah, so yeah, I think the obvious thing here about, comes back to Andrea's point about getting data collected now so that people in the future can sort of make the right decisions then. We should move on to questions. Steve, if you can put them up for, thank you very much, because we've only sort of got 10, 15 minutes left. I'm going to stand up for this because I can't screw my head around quite that far. So our specifications now say average steel carbon intensity to be less than 1740 kilos of carbon per tonne, which is a UK construction average. Is this the best way to realistically drive demand for low carbon steel? So putting an average steel carbon intensity into a spec, is that the best way to drive demand, or are there other ways to do it, Roger?
I think we should be starting to think about kilos of carbon per square metre in your building, because there's all kinds of other choices you can make about materials of construction, wood,
Sure, but once you are using steel, is it a good approach or not? Because what that could incentivise is just everyone to go and buy EAF scrap-based steel, right?
Yeah. I think that you still have to go in that kind of direction. I would encourage that or lower.
You'd encourage that, okay.
As
Dave?
an average.
Well, I think to talk to Walter's earlier point, it should be a little bit more granular than that. I would hope that it would be looking at kind of averages and values based on the product, because they can vary massively. And it depends on exactly what kind of product. So the average for UK rebar is about 760 at the moment in terms of global warming potential that includes processing and all the other kind of elements in it. So that's quite different from that, but you would be looking to specify that for rebar rather than that figure.
Yeah, okay, so different figures for different product types. We've got a microphone, so Penny can add her question, please. Thanks.
Can I chip in there, Will?
Yeah, go on.
Okay. So I think I think
I'm sure.
Penny's kind of quoted a British constructional steelwork average, and again picking up your point, that speaks to section. Doesn't speak to plate. Doesn't speak to the material used for decking or the material used for cladding. So the thing is, your spec, if you're going to try and play it that way, you're really going to have to pick out the product groups, and you're going to have to set a target that's appropriate for that product group. But you will find variance in your supply chains. You really need to start speaking to your supply chain. You will find people in your supply chain who can easily meet that 1760 target, if it's 1760, 1740 target, and you'll find others who will find that a challenge. So I think really what you've got to do is understand your supply chain, the particular construction supply chain you're working in, and then if you're looking to drive change, that change needs to be relevant to them.
Penny, did you want to?
I think we've had this conversation many times, but we're trying to get to a point where we're fully engaged with the supply chain, etc. That's fine. We can work with it and we can drive carbon down. We've got really high-profile projects where we're doing that. But there's also the churn projects where you do a tender design and you have to have something in there if you're trying to push the market to signal a demand for low-carbon steel. And I agree that we shouldn't be saying that 50% of the steel should have 50% recycled content, because that's pushing it down the EAF route. So the reason we've gone with 1740 is that it allows that flexibility, because we can't be specific about plate and different sections. We're saying for general structural steel, that allows you to have the plate, which we know comes from BOF, so it's going to be higher than that. It allows to have some EAF steel. And so when you look at the total tonnage used on the project and you multiply the relevant carbon factors, as long as we're netting out an average which is at least where the consumption average is for the UK and a little bit below that, then in theory, in my view, it seems to be the best compromise at the moment to try and still signal that we want to be doing something a bit better than what is average. That was the basis for the question, which I couldn't fit in the word limit or the character.
If I could just respond, Penny, if you had a light gauge application, you wouldn't be able to hit that target.
Yeah, this is for like primary frame.
So if you're building everything out of tubes, again, it's going to be blast furnace space, isn't it? Which is the difficulty of this,
The thing is, if you had a plate-intensive structure, you'd probably struggle to hit that target. I think you want a simple answer, and the fact of the matter is that there isn't a simple answer. The best way to get a result is to deal with your supply chain. We've seen it in the work that we've done. We've worked with certain suppliers who would even find that target a challenge. And yet you go down the supply chain, you work with a different group of people, and then actually do it quite easily. So the problem is that we've already started to transition. We started to transition the first time we built an electric arc furnace. But the problem is that you guys want to go faster than the natural transition. If you take China, China expanded massively whenever it was, 10, 15 years ago. Current consumption is 900 million tons per annum. They have naturally transitioned to now do an electric arc furnace manufacture of 100 million tons, not driven by sustainability, not driven by anything like that, just driven by the fact that they're producing scrap. And the best way to process that scrap is an electric arc furnace.
We need to keep going through a few questions. If that didn't answer, then let's pick this up after. It's a really interesting problem, isn't it? Why is the UK, this is maybe a difficult one to answer. Why is the UK falling behind the EU in terms of decarbonising its primary steelmaking? I assume it's not just the relatively high UK energy prices.
It's not a difficult, it's a very, very easy question to answer. It's all about government policy, really. I mean, it's rule of thumb to put an electric arc furnace into either Scunthorpe or Port Talbot. You're looking at least £2 billion per site, I would have thought. I mean, that's based on some work that's been done internally. I can't speak for British Steel. That's not including all of the energy work that needs to be done at the same time. So that's just the stuff on our site. It's an enormous amount of money. I mean, even a Musk or one of the oligarchs would blanch at that kind of money out in one go. So it is to do with government policy at the moment, I'm afraid to say.
Yeah, so a lack of support, basically.
Yeah, I mean, and other people are excited. I mean, Netherlands has just agreed hydrogen infrastructure for the site at Amouda. Germany's just agreed state subsidy, so has Belgium. So there's quite a lot of states that are sort of looking to this as a priority. And it seems to me, speaking personally, that we've kind of somewhat dropped the ball or are kicking the can down the road on this.
Yeah, and I think it is well known as a hard to decarbonise sector. So you would
hard
sort of
not
expect
impossible. So it needs,
technologically possible, but yeah. I guess I might be best placed to try and answer the next question, which is, will building targets, i.e. LETI, etc., be adjusted to acknowledge the local versus global discussions tabled by the panel? Currently, those targets lead to EAF section specs. So unless anyone else wants to come in, what I'd say on this is, because we're grappling with this at the moment on the net zero carbon building standard, and of course we're acknowledging the fact that when we talk about setting carbon targets, the quickest way to meet it when you're using steel is to just buy highly recycled EAF steel, because it's got a fifth of the carbon footprint. We haven't yet on the standard concluded how we're going to deal with this, but we have acknowledged that we need to do something more than just say, set a carbon target and get on with it. And we currently have the same problem with concrete and GGBS and things like that too. So we are looking at it, yes, but I can't tell you what we're going to do about it at this point in time. Next question, maybe. Is the best thing we can do today not simply to just use less stuff, i.e. design for minimum overall steel use?
I mean, why not? Definitely, yes. But that still doesn't for you individually, it might kind of, help your bottom line, solve a problem for you, but it doesn't solve it on a global scale. Pretty much it doesn't. So.
Agreed. As a manufacturer, we've got absolutely no beef whatsoever about, efficient design, using steel where it needs to be, using other materials instead of steel, because we have to appreciate that we are in a climate emergency. I don't think we can just stand here and say, no, you will buy more tons of steel, please. And we are, waiting for our ability to transition in terms of decarbonisation. And whilst we're awaiting that, I think we have to be responsible suppliers.
It strikes me that, a lot of the sort of material change stuff that we've discussed, and we didn't get much time to go through a lot of it today, but to do with hydrogen, electrolysis and all this, the speed of change on that compared to the speed of change that's being demanded by the IPCC and co, they're just completely different orders of magnitude. And so, if we're going to halve emissions in the next 6.5 years, it's not very easy to do that by just relying on steel making to halve its intensity in that time. It's not really feasible. No. So using less material, to my mind, use less stuff really is the quickest way to start slashing total emissions. today, although I agree that you do have to decarbonise the product as well, because there's only so far you can use less stuff. At some point, you still have some stuff.
Yeah, so there's other things that you can ask of your suppliers, and I do agree that you've got to kind of ask these questions. So that's one of the key things, is get into these discussions and ask them if they've got a science-based target that's set. Do they report to the Task Force for Climate-Related Financial Disclosures? And those are the kind of things that you would be looking for steel makers to be putting in place, which gives you some confidence that they are trying to get onto that trajectory, because there is this lag.
Yeah.
I think definitely demand is
so sort of supporting those suppliers who are trying to make the changes happen, who are trying to drive that progress.
Yeah.
And not just sort of closing our eyes to where it comes from. So that kind of actually leads into the next question, which might also be one for you then, Dave, which is there enough transparency and tracking within the steel procurement market to allow specification of steel from a supplier with a particular progress level? Like, do we have enough of this transparency?
So obviously, Responsible Steel was first released in 2019, and the version that we're talking about was September last year. And so it's early days to be able to get that kind of granular information, in particular about crude steels. And I mentioned earlier that kind of currently what's available is a little bit more closer to the product-based global warming potential data. And there's lots of discussions going on between CARES, Responsible Steel, and other stakeholders about, so how do we get the information into the marketplace that enables us to kind of move down these progress levels? And so, yeah, CARES has also got a kind of progress rating levels, the Rosette rating levels, which includes elements of this. But this is specifically targeted, well, I'm pointing to there, I'm talking about the progress levels. It's specifically targeted at the carbon, embodied carbon, and one other, the raw materials inputs as well. So, yeah, it's early days, which is why you need to be having those broader conversations as well with your suppliers about what are they doing to decarbonise, and not forgetting the other ESG factors, labour rights, human rights, ethical business practices, transparency, asking for that transparent reporting.
Yeah, Roger?
I just feel a little bit depressed by this discussion, because I think we should all be a lot more ambitious than we currently sound like we are. I think all those specifiers in this room should be demanding steel at 500 or 400 or 200 kilos of CO2 per tonne. You won't get it overnight, but there's plenty of other parts of the world where that's happening. In Scandinavia, there's 5 plants coming, which will be up and running in the next 3 or 4 years, making either hydrogen steel or mini-mill type steel. We should be demanding that. We should be forcing people to accept more reuse of steel, and of course reusing structures where we can. I don't think the discussion in this room just recently has been ambitious enough to really deliver the climate change that we're after. So sorry for a little rant there, but that's...
No, I think it's good. And I think it's probably quite a good point to end on, actually, with a bit of sort of oomph behind it. I think from listening to you speak, I mean, the main messages I think I've taken away from this discussion is, number one, it sounds really hard to decarbonise steelmaking, and it's not going to happen overnight. So as you put it, pushing and driving demand is important. I think for me, it brings it back to the reason why we're all here today, which is mostly about how you reuse what you've already got, is more important than ever, because that's clearly going to offer us much bigger carbon savings in the here and now, and allows us to sort of tackle that big IPCC problem. And I just want to sort of, as a sort of final reminder to you all, just to bring back up this topic of using material efficiency. So we talked about using new steel efficiency. We previously talked about using reclaimed steel efficiently. And I think just making sure that we're doing the numbers on every project, whether it's new or reclaimed, to make sure we're minimising total carbon as far as we can for the planet, not just for our project, has to be the sort of key to moving forward on this. So with that, I guess we'll end our session. Thank you to the panellists as before, and thank you to you all for your questions.